Yes, welcome to the second session, an outline of what Industry 4.0 or the history or the transition between 1.0 to 5.0 vis-a-vis the mechatronics. This is a visual journey we want to go through to look at the industrial revolutions and how mechatronics has evolved to become the backbone of modern manufacturing. And what is this mechatronics? Maybe people may be asking many questions. What is this mechatronics? And what is this Industry 4.0? That is the language that is there in terms of engineering. Just to look at overview, during the World War I and World War II, there were deficiency in terms of finding the skilled people to work in many countries or to work in many industries. So there were what we call industrial revolutions, a change in the industry past the world wars or the civil wars that were transforming how goods are produced, were transforming how this production is driven by technology, were transforming how the energy resources were utilized or developed or harnessed. At the same time, how innovations were moving from point A to point B to change the society. So this is a key milestone of Industry 4.0 and the journey to mechatronics. Mechatronics just a synergy, integration of mechanical engineering. When you say mechanical, it is just a motion of components, things like automotive, things like aviation, things like material metallurgy, things like heating, ventilation, and maybe air conditioning. Things like production are part of mechanical engineering. So how do they integrate? So mechatronics just an integration of mechanical engineering, electronics, computer science, control systems, and also how you automate these systems to design and operate intelligent systems. So that is what we call mechatronics. In simple terms, it has the aspect of mechanical, it has the aspect of electronics, and then it has the aspect of control for the purpose of automating the design and operate intelligent systems. Understanding this evolution will normally help you to explain how mechatronics has become the key enabler in Industry 4.0 and 5.0. I know 5.0 is emerging, it is coming. So we can look at our history, look at this chart. The color R, I'll just go direct to the evolution or timeline of what we call industrial revolutions. What were there? So let's go to these evolutions. The first, what we call industrial 1.0 or industry 1.0. Industry 1.0, when you look at the history between 1760 and 1840, we call it as mechanization, in the sense that we develop systems to help us transition from manual labor to machine-driven work. Things like steam engines, things like water power, maybe mechanized textile production. These were developed in those period, and because the system had this capability of doing the work, transiting from manual labor to machine-driven work, we call it mechanization, and that was the aspect of Industry 1.0. The key impact was to increase production capacity, but with limited precision. Just underline these keywords. The impact was to increase production capacity with limited precision. Let's go to Industry 2.0. 2.0, if you look at now the history between 1870, maybe I was not there, but we're just looking at the history, how the industry has been developing. 1870 and 1914, this is now what we call the mass production and electrification. Mass production and electrification, such that electricity was now the power source. One way is the key features of this one is what we call electricity as the power source. Number two is we develop assembly lines to divide or specialize, or what we call discriminate labor, in the sense that every person knew their roles, and every machine line had somebody who were doing that work. That is mass production and electrification between 1870 and 1914. That is what we call Industry 2.0. There were inventions of things like telegraph, telephone for the purpose of communication. The impact of this was to ensure there's affordable mass production. Like, for example, the Ford cars, development of Ford cars. You can look at that history. That's when the Ford cars came to ensure that there was affordable mass production. That is Industry 2.0. We went ahead to come to Industry 3.0 in 1960s to 2000. People who were born during that period, I think even me included, 1990s, even me included. So you can find this period, there were automation and computers. That is the birth of these systems. Like they were using things like electronics. This is actually after World War II. That's when there were deficiency in terms of skilled labor and also how automation was carried about in their industries. So this is where there were a lot of use of electronics, PLCs, just programmable logic controls. There were use of CNC machines and also robotics. That's when now these features came into, and we call it Industry 3.0. We can also look at the introduction of what we call the automation and industrial IT systems. This when there were integration of systems like CAD, computer-aided design, computer-aided manufacturing, and also simulation tools to help in automating the systems. What was the key impact? The impact of this Industry 3.0 was about the increasing the higher productivity. If you look at the Industry 1.0, it was about increasing production capacity, but with limited what? Precision. If you look at Industry 2.0, it was about mass production, but there were no limitation on that aspect of automation and at the same time aspect of precision. But when you come to Industry 3.0, we are integrating CAD systems or CAM systems and simulation tools, and also development of IT systems, PLCs, electronics, CNC machines, robotics. This was to ensure there's higher productivity, increased or better quality, and reduced labor dependency. Because the paradigm about the world in terms of population was changing, and this impact was being brought about by the change in population. If you come to Industry 4.0, I think this is now the one most people know. This is where now, after 2010 and to the present, we have what we call smart and connected manufacturing. So they are born of Internet of Things, that is IoT. Things like cyber physical systems, big data management or mining, cloud computing, artificial intelligence, machine learning, smart factories with self-optimizing process. These are some of the key features that came into. So if you look at these features, we call it Industry 4.0 because they are now helping to smart and connect manufacturing. What was the impact of this? The impact of this is about real-time monitoring. So you monitor production in real time. You predict maintenance in real time. You improve flexibility in terms of customizing production. Flexibility such that you can allow maybe to do lean manufacturing. It can allow you to do just-in-time manufacturing. All of this manufacturing are designed in such a way that your manufacturing systems or production systems is flexible to adapt to any change. So that is what you call Industry 4.0. I think it's still even the present. But there's another one coming called Industry 5.0. Industry 5.0 is coming, which will be looking at the human-centric. How human-centric and how sustainable industry is. We call it emerging future. So this is the emerging technology which is coming up. We will be calling it Industry 5.0. It is not yet actualized, but it's coming up. And I know the key features of this will include things like how collaboration between humans and intelligence or machines, focusing on sustainability, green technologies, and personalizations, also using artificial intelligence and human creativity in production for the purpose of ensuring that you balance between productivity, environment, and human well-being. So this Industry 5.0 is yet to come. I think it's on the way, coming, maybe. That is was Industry 4 1.0 to 5.0. Okay. Let's look at mechatronics. Mechatronics, in simple terms, is, as I said, is the fusion, synergy, integration of mechanical systems, electronics, control, and computer science. In this sense, that the key elements of mechatronics, it includes sensors. Sensors are input devices that they collect data. If you say a sensor, maybe a temperature sensor, a motion sensor, proximity sensor, maybe a contact sensor, these sensors normally collect data from the environment. So the core elements of mechatronics is they must have sensors. Number two, actuators. Actuators, something like motors, hydraulics, pneumatics, which can help to perform physical actions. We call them actuators. And then you have controllers. Controllers like CPU, microcontrollers, PLC system, programmable logic systems. This one helps now to give a signal, then they help to control the movement of something from point A to point B. So they call them controllers. They give, like, let's say they make decisions. We call them, they are the brain of the mechatronics, controllers. Then you have a way of integrating them, putting them together, combining these systems for the purpose of ensuring that mechanical systems, electrical systems, electronic systems are able to rely together. Which means you need to program them, because you have the aspect of computer science. You have the aspect of mechanical. Mechanical, you need things like actuators. You need things like actuators, yes. And then electronics, you need things like sensors. Then you say controls, control, you need things like controllers. But for it to work, you need computer science, because computer science will help to integrate, because you are looking at giving it a code, either using a ladder, PLC ladder diagram, or maybe another language like Java, C++, or C# or Python, to ensure that when you are coding it, it's able to embed between these systems, or even the Arduino systems, to ensure that when you are coding it, it can integrate and then allow movement between one place to another. The application of mechatronics normally is in the robotics. Most of these robotics, you need to mechatronic systems. CNC machines, they also use mechatronics, because you need to program the PLCs to actualize the movement of motor, pumps, and whatever. You need to drones, also drones. Some of these automated machines nowadays they have drones. You need automotive systems. You need smart drives. So that is the application of mechatronics in robotics, CNC machines, drones, automotive systems, and smart devices. Let's look at a comparison between Industry 4.0 and mechatronics. We can look at Industry 1.0 up to 5.0, and also look at the role in terms of mechatronics. One, the industrial evolution. Industry 1.0, as I said, it was about mechanization, using of machines to help in to ensure that you minimize labor, but you are using machine to mechanize production. So this is Industry 1.0, which was between 1870 to 1914 there. So this, if you look at these systems, we have what calls the main technology that is there in Industry 1.0 is about smart engines, water powers. So in this steam engines or water power, their role in terms of mechatronics, one, there was no formal mechatronics, because it was purely mechanical systems. That's why we call it Industry 1.0. It was purely mechanical systems. So if you are designing systems that has all these aspects that maybe doesn't have mechatronics, then we call it Industry 1.0. Like in agriculture, those machines are used for plowing. Some of them, if they don't have mechatronics, then they will call it mechanized machines. So they now lie between Industry 1.0 and they are just purely mechanical systems. Then we have Industry 2.0, where now after doing mechanization, we brought in aspect of electrifying electricity, where in the core technologies is now putting electricity, and then some of the assembly lines or division of labor. Then in terms of mechatronics, their role is there was some early integration of electrical drives and some of the motors with mechanical systems. So there is in Industry 2.0, we have an aspect of mechatronics, if you do a comparison, which means integrating this electrical system to ensure that it drives motors. which are now mechanical systems, it had the influence of mechatronics, or a lot of, in terms of mechatronics. Then you have industry 3.0. We call it automation. Now this automation, after developing what we call the steam engines or water power, industry 2.0 came to now develop electricity to power motors after being invented, or even assembly lines to ensure that there is mass production. Out of this now, because people wanted to automate their systems, they came into innovating or inventing what you call, or adding electronics, PLCs and robots. So now this industry 3.0 was the beginning of mechatronics. Now adding the aspect of CNC, adding the aspect of robotics, adding the aspect of sensors and controllers. That was the beginning of mechatronics. But the current one we are using is called what? Industry 4.0, because this is smart manufacturing, in the sense that it has the Internet of Things, it has the AI, it has the cyber physical systems, which has been integrated to have the things like IT, processing, smart machines, autonomous robots, and even real-time monitoring. So this is advanced Industry 4.0. Then the one which is now coming, we call it Industry 5.0, which is now what you call human-centric. It will be AI and human collaboration. So that this one will be shaping the future technologies in terms of manufacturing and also production. So these are the preview of what we call an Industry 4.0 and mechatronics, from Industry 1.0 up to Industry 5.0. We can look at the application of this, as I said. What are some of these key applications in mechatronics and Industry 4.0 to 5.0? Industry 4.0, as I said, is used in smart CNC machines. It is used in automated guided vehicles. We call them AGVs. You know, some of these automatic vehicles. It can be used in what we call predictive maintenance using sensor data. We have Industry 5.0. You can use it in collaborative robots to work with humans. You can use it in intelligence, prosthetics, and human-machine symbiosis. That is in medicine. You can also use it in a eco-friendly system like in renewable energy, where they are able to detect real-time data and give you real-time data. That is Industry 5.0 and Industry 4.0. They are key applications. An overview or summary. Industry 1.0 to 2.0 was about mechanization and electrification. That's where we had the aspect of mechanical and electrical dominancy. Then when we come to Industry 3.0, this was the birth of mechatronics, because there was aspect of automation and aspect of electronics. Now Industry 4.0 is where we have mechatronics, looking at digital technologies and for the purpose of ensuring you automate your industries or smart manufacturing. Then 5.0 is now coming, where it will have the aspect of mechatronics, it will have the aspect of AI, artificial intelligence, and it will have the aspect of human collaboration. We call it human-centric. This is now sustaining human-focused manufacturing. In short, mechatronics, or in summary, mechatronics is the modern, or the backbone of the modern industrial revolution. It has evolved from simple automation in Industry 3.0 to advanced human-machine collaboration in Industry 5.0. So this is the outline of what we have covered today. History of Industry 1.0 to 5.0 and its application vis-a-vis mechatronics.